Let's understand potential difference and potential energy and work by solving a good example. See from the given figure, so two charges, source charges, one is a positive, one is a negative. So this is positive source charge, so this is negative source charge. So they located 2 points in the positive source charge P and Q and the negative source charge A and B. So we are having 5 questions. We can solve one by one. First one, give the signs of the potential difference Vp minus Vq suffix and the V suffix B minus V suffix A. So let's do that first. First we need to write the potential, only potential. Potential formula V equal to K capital Q upon R. So to find out the potential from source charge, I would like to take distance instead of the numbers. So it's easy to us if we can pick up numbers instead of the. Now if I consider this Q is at a distance of 4 centimeter and P at a distance of 2 centimeter. So this you can consider it is at a distance of 2 centimeter. Now you just calculate what is the potential at point P. The potential at point P which equal to K, here the Q source charge which is a positive upon R, here the R is at a distance of 2, and the potential at point Q we can write K source charge is a positive upon the distance is 4, and we need to calculate Vp minus Vq. If it is Vp minus Vq, just to subtract it, the two quantities Kq upon by 2 minus Kq upon by 4. So pull the common factors Kq. So 1 over 2 minus 1 over 4. If we can do that, we can get 4 minus 2 on the numerator and denominator 4 2s are 8. So Vp minus Vq, we will get that so we can write Vp minus Vq which equal to Kq. If you can do that LCM 2 over 8, we can get 1 over 4. So here we need not worry about the magnitude, since we worried about its sign. So it is having positive sign. So the problem is asking that what is the signs of the potential difference Vp minus Vq. So the potential difference Vp minus Vq, it is giving positive sign. So Vp minus Vq is positive. Now let's apply the same to the negative charge. We need to find in the second case Vb minus Va. For Vb minus Va, it's better to draw as first the distance from the source charge, let it be just like before. I will take this as 4 centimeter from the charge point A, so this distance let it be as 2 centimeter. Now I need to find VB minus VA. Now potential at B, I can write VB which equal to same K. Now in this case potential is a minus Q. Since it is a minus Q charge, K minus Q by R, here R equal to 4 centimeter. So the potential formula V equal to K Q upon R. But here our source charge is negative, that's why we need to take negative. Then the potential at A equal to same K minus Q upon by 2 centimeter. Now you can subtract it, VB minus VA, if we can do that. So K minus Q upon 4 minus of K minus Q upon 2. So pull the common factor, K, Q is common and here minus 4 is there and there plus 1 over 2. If you can do the LCM, K, Q which equal to minus 2 plus 4 upon by 8. So we can end up with VB minus VA which equal to KQ upon, so 2 over 4 which equal to 1 over 4. It means in this case also we got the sign of the potential difference VB minus VA. So that's what we need to find here, the sign, since it is a positive value. So even though it's a negative source charge, but the potential difference that you need to understand. And here it is potential difference VB minus VA which is negative, and in the earlier case P2Q it is positive. So potential is a scalar, so we need to mind the source charge sign also and from which point we are moving. Now see the B part in the same question. Give the sign of the potential energy difference for a small negative charge between Q and P, comma A and B. So here we need to again find sign. No need to bother about magnitude. Now this time potential energy difference for a small negative charge. So this time the test charge here is negative charge and we need to find the potential energy. So if you remember potential energy formula, U equal to at a point K times capital Q small q upon R. So capital Q is source charge and small q is test charge. R is distance between them. So as usual, if I consider the distance between Q2 source charge to a location Q is 4 centimeter for calculation purpose. So let it be as 4 centimeter. From the Q to P, I would like to take this distance as 2 centimeter. Now if I write potential energy at a point P equal to K, here the source charge equal to positive, that is capital Q I can take. In the test charge they are given small negative charge, so here I can take minus Q upon distance P at a distance of 2 centimeter. And similarly potential energy at point Q equal to same K test charge, source charge is capital Q, test charge negative minus Q, distance 4 centimeter. Now we need to calculate the potential energy difference points between the Q and P. So you have to subtract potential energy Q minus potential energy P. So K Q minus q upon 4 minus kq and minus q upon 2. So now if we can pull the common factors, k is common and capital Q is also common. I can pull little q outside. So at here you can get minus 1 over 4 and inside minus times minus it becomes plus, it's a 1 over 2. So if we can do LCM and we can get the potential energy difference U suffix q minus U suffix p equal to k capital Q small q upon 2 plus 4 by 2. So here you can get the 1 over 4. So here the potential energy difference is sign. So here nothing is there, it means the sign is positive. So UQ minus UP which equal to positive. Now similarly we will calculate about the potential energy difference between A and P. So I can do the same assumption from minus Q to A. So I can consider this as 2 centimeter, and from minus 2 to point B I will consider this as 4 centimeter. Now we can apply the same potential energy, now this time A to B. Now if I write potential energy at point A which equal to K, and this time my source charge is negative Q, so I can mention it as the minus Q, and the test charge is given minus Q upon A is at a distance of 2 centimeter, and potential energy at point B which equal to K minus Q upon source charge and negative charge negative Q upon 4 centimeter. So the source charge is negative and the test charge is also negative. Now we need to calculate the signs of potential difference from A to B. So potential energy difference A to B. So you can subtract potential energy A minus potential energy B. So minus times minus plus, so you can write directly K capital Q small q upon by 2 minus K capital Q small q upon by 4. So pull the common factor, K small q upon 1 over 2 minus 1 over 4. If you can do the LCM, so we keep on doing the same LCM, 1 by 2 minus 1 by 4. So you can get potential energy at A minus potential at B which equal to K capital Q small q upon 1 over 4. So here we need to bother about the sign. So we got this value is positive, so we can write this as positive. So potential energy difference UA minus UB is positive, which is nothing but it's greater than 0. So I hope you are the understanding the difference. If it is a negative charge, if it is a positive charge, and where you are moving from the A to B or from the P to Q. So according to the position moment and the source charge, the potential energy will be positive and potential energy will be negative.